Hello everyone. This is a functional demonstration for the mikroBUS driver. The hardware we are using is a BeagleBot or Pocket Beagle with the header soldered on its mikroBUS ports, another Pocket Beagle attached to a TechLab cape, and a BeagleBot Black wireless with the mikroBUS cape and a set of mikroBUS add-on clipboards from Microelectronica. Let's see the first demo with a few add-on clipboards on the Pocket Beagle mikroBUS ports. This is the kernel version we are using. We can see that the microBUS driver has registered itself as a new bus type, but there are no microBUS ports registered under the driver. For registering microBUS ports, we need to provide a suitable device tree overlay which contains the information about the microBUS port. Now we are enabling the device tree overlays corresponding to the microBUS port 0 and 1 on the Pocket Beagle. After a reboot, we can see that the microBUS driver has been loaded with the two microBUS ports, port 0 and 1 registered on the Pocket Beagle, and the default pin control pinmux settings are selected. You can see that as there are no add-on clipboards loaded, the default EEPROM probing fails. Once the microBUS driver is loaded and the ports are attached, we can see the corresponding CSFS entries. So the new device entry helps us to write a new manifest binary blob to the file so as to load a new add-on board. The delete device allows us to remove an added clipboard, and the rescan interface will trigger a rescan on the onboard EEPROM. Let's look at the manifester tool used to generate the manifest binary from a manifest configuration file. The usage of the manifester tool is as follows. Now we have loaded the Pocket Beagle microBUS ports with two clipboards. The Pocket Beagle microBUS port 0 has a geomagnetic click, and the Pocket Beagle microBUS port 1 has an MPU IME click. So now we are trying to write the manifest binaries to the EEPROMs on the clipboards. So we are probing the Atmel EEPROM driver, and then we are writing the EEPROM binary manifest binary contents to the EEPROM. We are probing the EEPROM on the microBUS port 1 and then writing the manifest binary contents corresponding to the MPU IME clip to the EEPROM. After a reboot, we can see that on the microbus driver probe, the EEPROM will be scanned for the manifest, and then the corresponding device drivers will be loaded. So we can see that the microbus port 1 has the MPU IMU click registered, and the microbus port 0 has the geomagnetic click registered. We can also see these devices under the IIO bus. Now let us remove these devices on the microbus ports and try adding new devices using the rescan interface on the microbus driver. So the rescan interface resistance entry helps us to trigger a rescan of the EEPROM on board the microbus port, which helps us to load a new add-on clipboard without probing the microbus driver again. So now we have replaced the clicks with the new clicks. We have the Ethernet click on the microbus port 0 and the micro SD click on microbus port 1. Now we are triggering the rescan of the EEPROM contents to load new clicks. So now we can see that the Ethernet driver has been loaded and the Pocket Beagle has connected to the local network. You can see the MMC SPI driver loaded and the SD card has been recognized correctly. Microbus port 1. Now let us see an example where the onboard clipboard does not have an EEPROM. So now we can write the manifest block, binary block directly to the new device interface on the microbus port, and we can see that the driver probe happens successfully and the device is registered. So we have the example of the RTC6 click on the microbus port 0 and it has registered itself as an RTC. To see the next example with the microBUS port on the TechLab cape with a pocket beagle. So now we have loaded the microBUS driver and we have an LED driver 7 click on the microBUS port 0. Like this corresponds to the microBUS port on the TechLab cape. Now we can see the brightness of the onboard LED changing. So in this example, we have a simple test script which is mapped to the two buttons, left and right buttons on the TechLab cape. And these buttons are mapped to the rescan and delete device interfaces on the microBUS driver. So when we press the right button, the delete device is triggered and the loaded clipboard will be released. And on pressing the left button, a new click will be the rescan will be triggered and new click will be loaded. So now we can see the color 7 click loaded. We have removed the color 7 click and then added the weather click to the microBUS port 0. Now we have removed the weather click and added a proximity click. Now let's see the third demo with the microBUS cape on the EagleBone Black. And now we have 4 clicks added attached to the microBUS ports. The microBUS port 0 has the LSM 303 AGR click, and the port 1 has the ambient 4 click, and then port 2 has the alcohol 2 click, and then port 4 has altitude click. So there is a small test script along with the manifesto repository which allows us to test the supported clipboards. Now we have loaded all the clipboards and we can see the corresponding IAO devices and the hardware monitoring devices. Thank you.